All right, here we go. Hi everyone, my name is Liran. How's everyone doing before lunch? Excited? Cool. So you were lucky enough to get two security talks, one after the other. So I hope you're all happy. But don't get too happy. No smiles, no nothing. We're talking about security. It's a very serious topic. So no one laughs during the talk, okay? Good. All right. So my name is Liran, as I said. I'm a developer advocate at Snyk, where we build developer-friendly security tooling to help developers build and create secure software. I'm also volunteering for OWASP in one of the Node-Goat projects that we have, as well as the Node.js Foundation through my work in the security working group. And I've actually authored and published the Essential Node.js Security book a couple of years ago. So I've been around security for a bit. But before that, I was team leader and developer for a couple of years, for more than a couple of years, of course. And I can totally relate to the problems and the challenges that we have as developers. And this is why this topic is so important to me to talk to you about. So what's a better way to start this conversation than to recognize that open source is awesome, right? Show of hands, how many people have contributed to open source? Amazing. How many are you using open source? Of course. So and it's obvious, right? We're using open source because it's a beautiful way to reuse other people's work. We can also contribute our own. It makes sense for us to focus on code that we need to write rather than invent the wheel. As a testament of that, we're seeing a huge spike, an enormous growth in open source software repositories, right? So like things like NPM soaring up and had added something like 250,000 packages just last year. So it's obviously like kind of the clear winner in terms of the competition, if so to say, around language-based registries, but it's not on its own, right? Java Maven is also showing an increased growth over time, and that makes sense because open source, again, is awesome. It's amazing. It allows us to do things. And it's written by people who are really trying to do their best, add value to users, create their projects and things that they are passionate of. But then I want to ask you and drill down into the problem of maintaining open source dependencies in your projects. And I'd like to ask you, think about it for a second. How many open source, how many dependencies, do you use in your projects? And do you know all of them? So let's pick a random one that probably everyone knows around JavaScript and NPM, maybe Express. So do you know Express? Do you know the maintainer of Express? Do you know how many dependencies does Express pulls in to work? Do you know if the maintainer of Express or those dependencies have actually done any security testing? What is their security knowledge? There's a lot of questions, and risk and kind of uncertainty when we are taking open source in terms of the risk that we're taking on ourselves in terms of things that we don't know and we can't always account for. And open source is just kind of trying to say, it's written by people, but at the end of the day, these are strangers. They are, by the way, amazing strangers, right? Unicorns who try to really help. That's kind of like the large majority of open source people trying to better the world through their contributions. But at the same time, it's not an easy task to also account for security. So to share from a report I published a couple of months back called The State of Open Source Security that really tried to look at a lot of data from GitHub, from NPM, from Snyk's internal database of our customers, and also a survey that I asked maintainers and developers to go and say, some thoughts about open source security in their projects. And in one of those questions were, for them to rate their security knowledge, the level of their security knowledge. And as we can see, 70% of maintainers who reply to this survey, anonymously of course, said that they don't have a strong security knowledge. It averages on 6.6 out of 10. Further on, we can ask more questions. One of them were, as open source maintainers, how often do you audit your code bases? So that means things like code reviews, things like automated security testing, static code analysis for security purposes, a lot of practices around open source security that we can do. And what we're seeing is, again, revealing the fact that 1 in 4 of those maintainers and the packages that they maintain do not go under any kind of security testing at all. That means, open your package JSON, your POM XML, whatever that is, count 1 out of 4, that 4 library did not go through security testing. And that already tries to kind of, I think, reveal the fact of what we are dealing with. in open source. Now, all of this is sounding to you maybe as data and servers, and it's kind of maybe a bit off, but to kind of adjust it with what we're seeing in the wild is, this is a tweet from Adam Baldwin. He's the security person in NPM, and he shared a couple of months ago this tweet where he said, I crunched the numbers this morning and I found out on NPM only 7% of maintainers have a two-factor authentication enabled, right? It already sheds, I think, a little bit of the problem that we have in open source security in terms of maintainers being aware of what they are building in terms of their security practices, in terms of taking security measures into account. We're seeing it I think Stefan mentioned it in the talk before this around, event stream, and ESLint scope was also a problem of a compromised account in a very popular library, accounted for, millions of downloads that we're seeing, but only due to the fact that some of the maintainers didn't enable 2FA. So cope that with a lot of the challenges and the work that needs to be done into security and then open source packages. That's a very hard problem space to tackle, and manage our dependencies. And it's not really scalable also to go and review each and every package, right? Because a typical JavaScript has hundreds or maybe thousands of dependencies. Some are direct, some are indirect dependencies that we'll kind of talk about in a bit. But just to show off an example, this is a serverless project. I wrote it with the serverless framework. What it does is pretty simple. It's also written on the screen. Fetch a file and store it in S3. As you can see, this is about 20 lines of code, so only 19, right? How many dependencies am I pulling in? 2 of them. AWS SDK and Node Fetch, which is the polyfill for fetch on the server side. And how many dependencies are they pulling in? So out of 2 direct dependencies, they're pulling in 19 dependencies by themselves. Now the thing is that I really want to kind of emphasize here is what is the amount of code that I'm actually pulling in from all of these dependencies, right? And that's a really, really large amount of code that I'm pulling in from other people who wrote those, probably also different people out of those 19 dependencies, different contributors, different maintainers into my app. So while I'm thinking that I am deploying my app, right, your app, everyone's kind of a flagship product here, you can imagine it, and you're deploying that to the cloud or wherever you're deploying it. In reality, your code is just a small bit of it. That's a small fraction of it. And all of those dependencies account for a larger attack surface and vulnerabilities that would, might at least get your app into trouble. So let's talk about application security challenges that we have today. Some of these are, how do we cope with Agile, right? Everyone are talking about, kind of, I think Agile is not really also that new, but let's pretend that we're talking about Agile and CI/CD and all of this stuff. And people are maybe doing multiple commits a day, maybe even just one commit every 2 weeks, right? Like kind of the standard Scrum thing. But how are we handling security in this perspective? Software delivery has sped up, but how are we handling, again, security in terms of ensuring that we're not delivering anything that is vulnerable to production when we deploy every day? Let's talk about lack of security focus, meaning the outrageous outnumbering of security people to developers. Meaning, there's a statistic that's about one security person per 100 developers. That by itself is already quite outrageous number. It means we can't really cope with all the applications and developers that are being developed in our organizations, and it makes it really hard for us to cope with it in time and give it a really good, responsible delivery. And maybe the last point is nobody really teaches application security, right? That's something that if you ask a lot of people how they get into InfoSec and AppSec, there's no really clear path of learning. Obviously, learning in general had increased in the recent years, but this is not something that you learn at like a basic computer science studies in university. It doesn't start from there. And this means that this expertise is kind of siloed. It's not really available to us developers in a very general perspective. So what happens when we fail to neglect, to address open source security? Let's talk about a problem that happened. I'm pretty sure some of you at least heard of it. Equifax. It's an American-based data analytics company that choosing it because it really became popular and a lot of people already know the name due to a data breach that they were a victim for a couple of years back that resulted in 100 and something million data records that got leaked for their customers. Which also happen to be, outside of like not U.S. residents. So what happened there is kind of interesting. They were using a component called, or a framework called Java Struts, specifically number 2, etc. And everyone can use it, right? There's nothing wrong with using that for the sake of using it. But at the time of March 2017, there was a vulnerability disclosed and released, and there was also a CV assigned, and there was like a patch, sorry, not a patch, an exploit script kind of appearing like a day later. So everything was kind of happening at the same time in terms of this vulnerability getting out and known to everyone, and that happened on March 2017. But then if you kind of look at it and forward back time, the breach, the data breach to Equifax actually happened, not the 5 minutes later after the announcement was made, but 2 months later or 3 months later. So there was, so this is like a story of there's like a 2 or 3 months time and an enormous amount of time for someone to understand that their application is vulnerable. Like you're shipping a very vulnerable application that is right now living in some production, staging, whatever environment that is accessible to people from the outside, and no one has done anything about it. Actually, a US government report about this data breach said, that this data breach could have been entirely prevented, right? Because if someone would have at least known about it, if you don't have time to upgrade it, fine, take it out of the internet, do something about it. I do not know what, but do something. But at the very least, do something. And no one did anything about it. I hope, that they knew, but maybe they didn't even know about it either, which is even worse. And this happens, right? It's kind of like one of the OWASP top 10, using components with known vulnerabilities, web security risks that people should pay more attention for. So obviously this happens because attackers are going to target open source software for the simple fact that one vulnerability that they're going to find in Express, Happy, React, whatever, Angular, whatever you want to use, Java Struts too, is going to be probably used by so many other people. And so that means and translates into so many victims that they can go and try their exploitation attacks on. So to give you, I think, another perspective on why this is such a complicated task is at Snyk, we're scanning a lot of open source projects, basically just scanning our customers like package manifests, so things like a log file and a package JSON and stuff like that. And we're trying to figure out also from the data that we have some information that is really interesting. So this shows, for example, that NPM, if you look to the right, NPM has 78%, so 78% of the time that we find vulnerabilities in NPM-based projects, it is found in indirect dependencies. So again, even if you have like maybe 5 top direct dependencies that you use in your projects and you do not have good visibility and management into your entire dependencies tree, that's really bad because 78% of the time we're probably going to find it in those indirect dependencies, not in the direct ones. So further, just to show how this issue is very complicated. So I want to go and just dive straight into some live hacking to kind of work with you together on learning of how these vulnerabilities happen in applications. And let's do it. So let's also do it kind of interactively, so play along. So this is a Goof TODO app, which it's open source and you can use it. It's used for education purposes, and it has a couple of vulnerabilities in it. I'm going to try and exploit them together and also see how does the exploit work, why does it work, and understand where those vulnerabilities are coming from. So I can go and say good morning, even though it's probably not so much morning right now, right? And send something. At the same time, if you have ideas of how to exploit this, go ahead. Give me some ideas. What would you do when you have user input? Yes, thank you. I see a lot of engaged people about security. I'm very happy right now. All right, so we're trying to do script. It's not really working. Do you have some other ideas maybe? What is it? Drop table. Okay. I'm gonna amuse you with that. All right, so I'm going to give you a little bit more context as we go along, so to make it easier for us. What I have in this application is I'm using also Markdown because the product asked me to kind of build something that has stuff like, there we go. Hello, Dave Days. There we go. Wait. Okay, so I can do stuff like bold strings and it prints it kind of pretty. So how would you add something like an XSS maybe that we tried before into this library when you have the ability to use Markdown? Yep, so with image or with links, and how do we create them? Something like this, right? There we go. Right? This gets interesting at this point. All right, so just to also kind of give you more context into what we're doing is, if so I'm using a library called marked. You can see it here. I'm using a library called marked, and even by the fact of just knowing what I'm using, it's a very popular library. You know, it has like 1 million weekly downloads. It's pretty popular, used a lot. It also has a flag to allow me to sanitize strings, which is why you're seeing, you know, why this is kind of acting like that. So it's kind of be secure, and it sanitizes it as I give the user input. It's not very friendly in those terms that the security flag is actually turned off by default. So this is something that, you know, we want to educate people not to do, but to enable it. So of course I enabled it, and this is why it escapes it. Some more ideas on how I can do it. Okay. Which is? I was gonna go with this one. Okay, so we tried this before and it kind of failed for us in this way. The thing is, the beautiful thing about open source is I could just go into marked open source project on GitHub or wherever that's hosted and see how it is sanitizing strings, right? And do it. So I'm going to tell you how it does that so that we can save that time for it. And what it does is basically it's look for this like colon thing, and it understands that I'm trying to add JavaScript and sanitizes it and looks for stuff like brackets like this one, and also sanitizes it and stuff like that. So even before knowing that, what I could do, what usually happens is people use things like HTML encoding, so they can try and represent colon in a different way. So I can do things something like this. Which represents a closing round bracket and a colon string. I can go and run that, and it gets further interesting, right? So actually marked, what it does is it detects also that I'm trying to use this HTML encoding, and it doesn't allow me to do it. The thing is, and this is where it really gets interesting, you know how front-end developers really love browsers and, you know, doing front-end work, because browsers are very, very nice and friendly. And if you have ever written HTML in the way that we have done it in the 90s, and you forgot to like close a div or a bracket or something, what would the browser do? Close it for you, right? So if I'm going to add some valid keyword for JavaScript so that this statement would be valid, something like actually the keyword this, which is a valid statement in JavaScript, what happens is marked, when it sees something like this, it doesn't go through the sanitizer because it doesn't recognize this as, you know, valid escape characters for HTML. But the browser says, well, buddy, I think you're trying to add a colon here, so let me close this for you, basically doing something like that, and then this gets validated. So if I'm doing this, I have XSS. All right, cool. Yay. Everyone are happy. Cool. All right. All right, so how to gain this visibility into our applications and what happens. So as I connected something, I connected this project through the Sneak platform, going into my Goof app and looking at my dependencies. Do not have internet, which is important when you present. So as I go into that, I can see all the vulnerabilities in my application, and I want to search for another one so we can try and find. No. Try it one more time. Okay, let's try that one. Like this. Cool. No one saw it, don't worry. It's a security session. All right, so internet is very expensive, I guess, in Lithuania, which is why we get so little of it. Want to try to help with that again? No. Sorry, not this one. This is the password. Okay, I can probably do it without the internet as well. So if this doesn't work, we'll just skip it. All right, so let's skip that. So anyway, I can see more vulnerabilities, and so let's go with the example of we don't need all of that, so I'll go with another vulnerability. My app also has different things, like maybe it supports things like regular expressions. So I have this regex online here that I will hope it will work a little bit for us. But what it does is allow me to kind of use regexes and debug and see how they work. So let's try and write a regex regular expression that's going to try and match some song strings as if we had tried to build something like Spotify. Who likes to write regular expressions? Good, this is good. Do not write regular expressions. But let's say you were convinced to do it. All right, so let's match something. So anyone want to give me a song name? I'm gonna go with something like Britney Spears. Don't stop me now. Okay, let's do that. All right, good. So how I would match it? I would try and good. And maybe try to get a capture grip and end it at some point. And maybe I will start with something like detecting all or most kind of strings. This actually works, but it only works to detect one of them. So I need something like a multiplier, so something like a plus that would get things like this getting matched. Great. At that point, I probably need something to match the space here. So I'm going to use it. And I have maybe some places I have a space, maybe some of them I don't have because I'm at the end of it. It doesn't still match it because I kind of need to get to the end of it and repeat this matching group. So I need another quantifier, something like this one. And this already works. And at this point, for me as writing regular expressions, I'm really elevated and I'm pushing that to production. So I'm seeing some faces that are like, you need to test it. Okay, let's test it. There we go. Works just fine. I'm going to test it like a security person. I'm going to add more of it to see if it slows down anything. Looks fine, right? Yay. We're the CI/CD people. All right, so what happens is, what if I give it something that it doesn't expect? Something like, an asterisk or just exclamation mark. So at that point, we're seeing that the regex debugger says catastrophic backtracking. And I can tell to all the backend developers here that if you see something red on the screen, that means something has gone bad. Right? So what's really going on here, right? As we've seen before, when we tried to match something as simple as that, we went into something like 24 steps to evaluate it, and that worked just fine. But as we're trying to put some malicious strings as an input, and again, this is user input that, maybe searching a song and you're trying to match it, we're seeing the regular expression engine having some problems. What kind of problems? I think we have internet, so we can go into the debugger. Yay. Was that, I think, premature optimistic? All right, so if this had worked, what we would have seen, of course, is the debugger going through something like hundreds of thousands of steps trying to evaluate the bad string. And that happens because the way that the matcher, the way that the regex at least is built over here, and it's not really a problem with regular expressions in general, this is the way the algorithm works, is it actually tries to match all of this, and it matches this part. And so it repeats everything. At the point where it's coming to a string that it has no regex token to match for, it's going to do something that the algorithm calls backtrack. It's going to go and try and be a bit less greedy in the quantifier, and then something like A to Z over here with the plus sign will not match all of stop. It will just match STO, and then the rest of it will get matched by something else, like maybe the other greedy quantifier, the asterisk. And as that doesn't happen, it also backtracks again. And all of this process happens in a very, in a way that is very not linear. Actually, it's a very exponential way, and it takes a lot of computation time from the browser or whatever is running this. Now, when this happens on the browser side, that's kind of like, it's kind of annoying, but that's not the end of the world. But what happens when you run something like this on something like a node server? So if we go and try to, we're saying that? Okay. Try to run something like this on Node, and I have it written before, right? So I'm trying to evaluate the same string, I think, yep, and giving it, best song ever, whatever, and trying to run it. It runs really fast. I'll add time so we can actually time it. That's really good. What happens if I give it a bigger string like we did before? Now it takes a little bit more time, right? Almost 2 seconds. And the more strings that I add, I'm going to add significantly more computation time on Node to actually do this. So in fact, what actually happens is I'm blocking the event loop. And if you're using something like a regex to match some strings that are incoming to your request, you're going to block any other request if someone is able to exploit a regex that maybe you wrote or exists in some other library that you're using. I'm going to stop it at this point, but you get the idea, and this is why regular expression denial of service attacks exist and actually had affected both Node Core and very popular Node libraries as well in the ecosystem. So how does this relate to the app itself? Let's go back. So what I have here is something like I can do attend dev days in 5 minutes. And what it does is it translates it to kind of like a humanized microseconds or milliseconds presentation of it. So if I go to Humanize MS, which is what I use in my project, you can see it's very popular, almost 1 million downloads as well. It's using MS behind the scene, which is kind of also used for JavaScript and in the front end and the back end too. So it's a very popular library to use. And at this point, I wanted to show you the idea with the regular expression that we had as example, so like you can already understand the context of why this is a problem. So how would we attack it? Let's see what happens. As I open DevTools and do something like attend dev days in 5 minutes. Let's do this again so we can catch it. So I'm actually sending an HTTP form into this URL/create. So I'm going to try and do that as well from the command line too. So something like content is worth something like attend dev days. So I have some of that here as well. And I'm going to pipe it back into something that's called HTTP, which is just a command line tool, as a form into localhost. Start create. So great, I created something, and it's over here. Probably that's the new one. So far so great. But what we want to do is kind of try to make this fail, right? To exploit this vulnerability. So let's do something like change minutes to minute A, or basically any other string. And as we do that, we see that maybe that doesn't really work, because if you look at the source code for MS, it actually does regular expressions to find out, where are you actually adding the time number, something like 2 days or 5 minutes. So what I'm going to resort into is maybe try to give it a longer string. So something like I can use sequence like this, which means I am formatting the string 1 with no separator and repeating it something like 100 times. So I can go and combine these two things together and do something like, let's do a shell evaluation thing and do something like sequence format 5, no separator, and repeat it 60,000 times. And that actually works pretty well. If I look at the website, right, I have infinity, which is, makes sense. I didn't expect anything else, but it didn't fail the problem. So let's try something else. And for that, let me open HTOP so we can see how applications, or specifically the node process, is being used in my server here. So if I went ahead and tried to change it to minute A, at least let's see if that works, is you can see that it's already taking a bit of time. My node process over here is utilizing as much process as it can, and everything that I try to add doesn't work. So in like 5 seconds right now, it's gonna go back and the event loop got freed and everything works. But this again shows you how this vulnerability, a regular expression denial of service that exists in MS, and by definition also exists in humanized MS because it's being used inside it, is actually affecting my application. So even if this is, you're not trusting your self-derived regular expression, some other libraries might be doing it and could get you vulnerable. So let's get back to the presentation. So what's the solution to all of this? So this is kind of the end of it, and I'm going to leave time to questions as we've gone through some topics and some demos. So we really see this as a team culture, right? Both working, at Snyk and both being involved with the Node Foundation. We're seeing that a lot of security awareness and knowledge needs to really happen and make it to developers so that they actually we know that developers want to own security and build and release secure applications, but it's also like a team culture where we need to make this part of what are we expecting to go out. So expecting to ship out a secure quality application. The next thing is process. A very maybe a bit archaic kind of security solutions would maybe tie into your process at the end of a release in like after 6 months or something like that. So this, as we said, these are ppSec challenges that doesn't really work with what we have today. And what we have today is really fast iterations of providing value. And that means we need to work with processes and in workflows that developers work at. So for example, if you're using something like Snyk, if we detect a vulnerability in MS and we can, we know we have we have a fix for it. So what we can do is we can actually open a pull request to your repository, and we are going to change 2 files. We're going to change the log file for npm, and we're going to change the package manifest, the package JSON, and upgrade to the most minimal version that you have in order to provide a fix. So we really believe in this kind of, we want to take actions, not just give you and tell you that the report says, something is vulnerable, but also tell you, well, it is vulnerable, but you can actually fix it. And, you just have to see that all the tests maybe pass in the pull request, that security upgrade didn't hurt anything else, and merge it. So it's a lot about process, and the tooling itself, being, kind of working together with the process. So the workflow and the tooling is very developer friendly. It has a really good developer experience in the way that you can really use it, adopt it, and not think of security as something that is an afterthought, or it's something that security people will take care of. It's not. It's really part of what developers should actually do. So open source security takeaways, and kind of summarizing this. Please find vulnerabilities, use tooling, whatever works for your company, for your team, for your open source projects. Fix vulnerabilities, upgrade to the minimal version that you can. So for example, some some fixes may be available in version 4 where you're in version 3, but that's a major upgrade. Maybe you don't want to move that fast. You just want the security fix. So maybe you need smart tooling to be able to do those decisions. You can also patch vulnerabilities. Some tools provide that, so you can patch them even if there's no official release, and prevent adding vulnerable modules. So a lot of time what we can do is, as maybe team members would be able to find and add modules as their package into package JSON as part of maybe a feature they're developing or a backfix or something else. We're able to fail the build with that and say we found a vulnerability, so please don't do that. So thank you so much. Please use open source responsibly. It's very awesome. If you want to talk to me about OWASP, Node.js, security, testing, anything else that you want to talk about, I'm really here throughout the conference. And thank you so much.